Welcome to this activity about indefinite integrals, in which we're going to use integration by substitution to compute the following integrals. First of all, let me make a reminder on integration by substitution. The first rule is the power rule. So it says that the integral of u prime of x, u to the power of n of x, dx is equal to u to the power of n plus 1 of x over n plus 1 plus c if n is not equal to minus 1. The second rule is the exponential rule. It says that the integral of u prime of x exponential u of x dx is equal to exponential u of x plus c. And the third rule is the logarithmic rule. It says that the integral of u prime of x over u of x dx is equal to ln of the absolute value of u of x plus c. So please memorize these three rules. Now, the strategy is each time you have an integration by substitution, or you are planning to use an integration by substitution, is to choose your rule. Then you check that you have the appropriate form of your rule, and then you adjust your integral, maybe by multiplying by constant and dividing by the same constant, and then apply the rule. So let's apply this on our examples. We'll do it for the first one here, the integral of x plus 3 to the power of 10. And here, my candidate rule is the power rule. Since I have a power, so I will try to use the power rule. So I will identify my n, which is 10, my u, which is x plus 3. So if u of x is equal to x plus 3, then u prime will be equal to 1. Now I will check that I have u prime u to the power of n, and of course there is a hidden one here. So I can read this integral as the integral of u prime u to the power of n, and I can apply my power rule, and the power rule says that the integral of u prime u to the power of n is u to the power of n plus 1 over n plus 1 plus c. So my integral here will be equal to x plus 3 to the power of 11 n plus 1 over n plus 1, which is 11 plus a constant c. Okay? By setting u of x equals x plus 3 and n equals 10. Now, for the second one, we have x squared times x cubed plus 2 squared as an integrand. Okay? So again, here I have a function to the power of 2. So my candidate is the power rule. I will set my n to 2. My function u of x is x cubed plus 2. So if u is x cubed plus 2, u prime is 3x squared. Now, I will ask myself a question. Do I have u prime u to the power of n? Almost, yes, because we have the x squared. We miss only the 3 here. So if I try to multiply here by 3 and divide by 3, I will not change my integral, and I will get u prime times u to the power of n. So let's write this differently. Let's adjust our integral first. So we're gonna write it as 1 over 3 times the integral of 3x squared times x cubed plus 2 squared dx. And here we can see clearly u prime u to the power of n. Okay, with n equals 2, with u of x equals x cubed plus 2, and u prime is 3x squared, and there is a constant 1 over 3 in front. Okay, so it's equal to 1 over 3, and we apply the power rule. It gives x cubed plus 2 to the power of 3 over 3 plus a constant c. Of course, you can write it as x cubed plus 2 cubed over 9 plus c. Now, next one. Here we have x over 1 plus x squared. From the set of the three rules, I suspect the third rule to be the appropriate rule, since I see a fraction here. So let's try to apply this rule, which is u prime over u, which gives ln of u. Okay? So let's check. So if I'm gonna use u prime over u, so the u will be this function in the bottom here. So this is u. If u is 1 plus x squared, u prime is 2x. Now, do you have 2x in the numerator? Yes, almost. You just need to multiply by 2 and divide by 2 to get the 2x in the numerator. So let's apply by 2 and divide by 2. So I will write my integral as 1 over 2, the integral of 2x over 1 plus x squared. And here you can see the u prime over u inside the integral. So it's equal to 1 over 2 ln of the absolute value of u of x, which is 1 plus x squared plus c. Let's move to the fourth one, which is the integral of 3 over 2 minus x. Again here, my candidate is the logarithmic rule, which is u prime over u. So I will set my u as 2 minus x. And if u is 2 minus x, u prime is minus 1. Now, do you have the minus 1 in the numerator? Yes, you can obtain it by multiplying by minus 1 and dividing by minus 1 and put the 3 outside the integral. So let's rewrite this integral again. We can write it as minus 3 times the integral of minus 1 over 2 minus x. So we added 2 minus signs here and I put the 3 outside, so I get this integral, which is of the form u prime over u. So the result will be negative 3 ln of the absolute value of 2 minus x plus the constant c. Next one, the integral of exponential for x. Here, when you see an exponential, of course, you're going to use the second rule, which is the exponential rule. And the exponential rule says the integral of u prime exponential u is exponential u. So my u will be 4x. This is u. So if u is 4x, u prime is 4. And you need here again to multiply by 4 and divide by 4 to have u prime exponential u. So let's rewrite this integral again as 1 over 4. The integral of 4 exponential for x dx. And here you can see u prime exponential u. So it gives 1 over 4 exponential for x plus c. Next one. Number 6, exponential minus 1 minus x. Again, here the u will be 1 minus x. So the u prime is negative 1. You understood that we can multiply by negative 1 or multiply by negative 1 twice. So we're going to write it as negative, the integral of negative exponential 1 minus x. And this minus sign here represents u prime exponential u. So we can write it as minus exponential 1 minus x plus c. Next one. The integral of 1 over x ln of x. Of course, here we don't see a clear shape of our integral, so we're gonna try to rewrite it before making this integral. So I will write it as 1 over x over ln of x. My recommendation is when you see an ln inside an integral to search for 1 over x, because the 1 over x is the derivative of ln of x. So if you write it this way, guys, you can see that it's of the form u prime over u. So it's the third rule, the logarithmic rule, So you can apply the integration by substitution here, and you will get ln of the absolute value of ln of x, because the u here is ln of x. Okay, plus c, of course. The integral of x over 3x squared plus 1 squared. Here, my first thought goes for the third rule, because I see something like a fraction u prime over u. But if you try u prime over u, guys, you're gonna fail, because if you take the u as 3x squared plus 1 squared, so let's try, u is equal to 3x squared plus 1 squared. The u prime is not equal to x. The u prime will be 2 times 6x times 3x squared plus 1, which is not equal to x, and you can't obtain this by adjusting by constant. So let's try something else, which is writing this integral with negative power. So we can write it as the integral of x times 3x squared plus 1 to the power of negative 2 dx. And here we can see clearly that if you use this as u prime is 6x, and here you have the x, you need to multiply and divide by 6, okay? So if I multiply and divide by 6, I will get my appropriate form. So I will divide by 6, I will multiply here by 6, okay? And I will write it 3x squared plus 1 to the power of negative 2 dx, and I will apply the power rule, okay? So it gives 1 over 6, 3x squared plus 1 to the power of negative 1 to the power of n plus 1, and the n is minus 2, over minus 1 plus c. Of course, you can write it in another form, which is minus 1 over 6 times 3x squared plus 1 plus c. So we are done with this activity. Thank you for your attention, and see you in the next videos.